very fast presenting to you my work on online resource sharing via dynamic fairness, joint work with Sid Banerjee and Avatardos. So first of all, what is online resource sharing? It's a very simple problem. You have multiple agents and one indivisible resource that you allocate over and over multiple rounds to one of these agents every round. We assume that the agents have stochastic values. And one important difference with mechanism design here is that we cannot charge the agents money because we assume we're in some setting where, for example, scientists are setting a telescope and we do not want them to, we don't want to charge them money just to use a telescope. It's a public good. And the goal of our work is to allocate the resource with the mechanism such that we get robust utility guarantees. What this means is that we want every agent to be able to get total utility as an alpha fraction of their ideal utility. An ideal utility is a benchmark which measures how much utility an agent hope to get without violating the fairness of the other agent, without overgetting the good. And we want this guarantee to hold no matter what the other agents are doing, even if they're acting adversarial towards a certain agent. That's why we call them robust utility guarantees. And this is a very strong guarantee, so it has some very nice properties. First of all, it's a nice fairness guarantee because everyone can guarantee some fraction of their utility, some utility, no matter what the agent do. And we also get a lot of equilibrium guarantees, price of anarchy guarantees. As I said in the beginning, we allocate this good via the dynamic maximum fair mechanism, and we have two types of guarantees. First, if the values are independent across time and they come from not worst case value distributions, then we saw that every agent can guarantee total utility as almost all of their ideal utility. And then we have some results for dependent values where there's some dependence across rounds. And here we saw that every agent can guarantee a gamma fraction of their ideal utility, where gamma is a parameter that measures how close to independence the values are. And you should copy my concepts right out there to see the exact statement, the exact guarantees in more detail. Thanks.